Hi guys, once again, but this time please don't hate me. I'm trying my best at least to be with you during the off day, okay? And this also instructions, but don't tell Mr. Jim, okay? So anyway, we just spend a nice time together. I'm trying my best at least to represent something for you, especially in mathematics. You know that the math needs some practice, and always from time to time we need to have different questions. And don't forget that I'm helping you too much during my class, especially in math, because I know that exactly not all of you are very good in math. Anyway, today I'm going to continue our ninth chapter. Okay, chapter number 9, which says about the percentages and about the square roots and the roots and the perimeters and many bases of the mathematics. Especially, I want you to grow up with a very high quality evaluation. So please listen to me this time, and of course, also with the Socratives, I will try my best to find out some kind of problems which we can solve it together. And at the end, I will appreciate your readiness and your practice. And I know that you are going to try your best to find out the solution and to reflect to me that you are very good students. Okay, so just like warming up, it's exactly as we have already started during the classes. Warming up, simplify each expressions here. 6 power 2. Yes, I can hear everyone. This exactly means 6 times 6, right? Right? 6 times 6 equal 36. Excellent, excellent. So 2, 11 power 2, it means 121, right? So whenever we have that one, we can have the calculator here beside us always, and we say 11 times 11, it will be 121, right? So in this case, we will go directly to the next step for us. Negative 9 times negative 9. Of course, if this one scientific one, it will help us. Negative 9 times negative 9. I hope that it works. I doubt. No, it's wrong, of course. It's not negative 18. It's exactly 81. So number 4, open brackets 5 over 6 squared means 5 over 6 times 5 over 6. Of course, always the multiplication in this case, the numerator times each other and the numerator times each other. So 5 times 5 equal 25 and 6 times 6 equal 36. So the results will be 25 over 36. We can write it too. Why not? We do have everything here. So it will be 25. I hope that to write it properly. 25, right, over 36. This is the result of our problem. So all of that is very simple thing. Write each fraction as a decimal. So 2 over 5. I think in this case exactly very simple for us to consider the calculation. Here like 2 divided by 5 equal 0.4 means 0.4 as a fraction one. 0.4. It means equal 0.4. So the next one also for us 5 and 3/8 or 3 over 8. So in this case we'll make it as very simple thing. We'll say the fraction first, 3 over 8 equal 0.35 plus 5. It will equal 5.378. I hope that Mubarak is listening now, is naive to know exactly how did I solve it. Also the second one, also number 8 here, whenever we say that negative 1 and 5 over 6. So we can say that 5 over 6, 5 divided by 6 equal 0.83333. Okay, plus a negative 1. So it means it will be in this case what? Equal negative 1.38 and repeating digits of it. So in this case, I'm sorry, this is wrong, yeah, I just yeah, I invert it, just like I wrote it different one. So in this case it will be point and then 8, and the 3 is the repeated digits, right? 8, 3 repeated digits. Anyway, so by this way we'll go directly to the next one, and we'll see exactly what are the objectives, as I have already used to do with you with every lesson. Don't accept any lesson, my subject or any other subjects without objectives. You must know exactly why must you listen to me? Why did you need to hear your teacher, and what are the targets of your class? They are the objectives, and they are the targets which make you listening and doing all your work. That's why we have to look at the objectives first. Evaluate expressions containing square roots, and we must know what are the square roots and what are the radical numbers, what are different types. I will give you the vocabulary, and it explains all the terms which we need to understand. Classify numbers within the real number system. So now we'll go directly to the vocabulary. Instead of increasing my speech to you, say that square roots and perfect square are real numbers, natural numbers, whole numbers, integers, rational numbers, irrational numbers, and terminating decimal, and of course non-terminating decimals and repeating decimals. So let's start with that one to identify what are the square roots. It's a number that is multiplied by itself to form a product, which is called the square root. Square root of that product, we can say that the operations of squaring, of finding and finding square root are inverse operations. That's why we'll find out this is the radical symbol for the square root. That's why it represents the square roots exactly. So don't forget, it's called as a radical symbol, because whenever I was in your age, I don't memorize that the radical symbol, it's exactly representing the square roots. But now we must say that positive real numbers have 2 square roots. For example, I do have square roots of or 4 squareds. 4 squareds means 4 times 4 equals 16. Also, the square roots of 16 equal 4. Why? Because it's a positive square root of 16. Also, for the negative 4 times negative 4 means negative 4. Of course, as you see, negative times negative equal positive. We have already covered before in algebra. So negative 4 times negative 4 equal plus 16. And of course, root square of plus 16 equal 4. But negative root square of 16 equal negative 4. And negative 4 in this case is a negative square of root 16. But we mentioned after that, if we do have a negative root square, what will be the situation? We'll explain it. Now, the non-negative square root is represented by the radical. If you remember that, again, I rotate that one circled as a radical symbol. But now we are saying it as a radical symbol, or the negative square as a positive one. The negative square root is represented by the negative signs with the radical symbol or the square root. So a perfect square is a number whose positive square root is a whole number, like 1, 2, 3, 4, all the whole numbers. Some examples of perfect squares are shown in the table, like here. Of course, 0 exponents or power to any number, it is the same 0. And also 1 power or exponents of whatever the number, it's still 1. 1 times 1 times 1 times infinity 1. 4. For example, 2 power 2 or 2 exponents 2 equal 4, and 3 power 2, 9, and so on. So whenever we have all these bases, we must know that the math, especially in the radical symbol, says what? The expression of the root square negative 36 does not represent a real number. Of course, it's a negative number, because there is no real number that can be multiplied by itself to form a product. Again, negative times negative give you plus, right or not? But negative times plus equal negative, positive times negative equal negative, but it's not a real number. Why? Because we are talking about here a positive or a negative number clearly. Example number 1 for our topic, finding square roots of perfect squares. Find each square root. Here I want to hide all the answers, but it's not representing the answers. It's exactly like as brainstorming together. Square root of 16, what does it mean? It means what number squared equals 16? Of course, 4 power 2, excellent. I can hear Halim and I can hear Rawat say that. And I can also the others, Walid, saying it. I don't like to say different names, otherwise you'll be angry for the people who I miss their names. Anyway, so if I have the second example, negative root square of 9. Think about what is the opposite of the square root of 9. 3 power 2. Yes, 3 and exponents equal 2. So 3 times 3 equal 9. But if I have negative root square of 9 equal negative 3. Negative square root, it means negative 3, as exactly mentioned here. Whenever we look at that one, we must understand, and I'm sorry again for that dash. Anyway, I don't like to just waste your time by erasing or copying it again. The second one says finding square roots of perfect squares. Perfect squares means a whole numbers or a positive numbers. Find the square root of root square of 25 over 81. Of course, you will have it numerator and denominator. The numerator, we must think about the squared equals this ratio. 25 over 81. 25 means 5 power 2. 81 means 9 power 2. So in the same position, we can write the same fraction, enclosed in brackets together to say that 5 over 9 squared. It's exactly as we found it in our calculator. Also, we can make sure, but we have already tried that before, 5 times 5 and 9 times 9. Also here we'll find out that the value here in a positive. Why? Because the original root square fraction was in a positive one. Also, whenever we look at the second example, here it means root square of 2 equal 4. Also, root square of negative 5 equal negative 5. So it's exactly similar to the previous one. And we don't like just to repeat what did we say. The statements here explains to us the square roots of many numbers like root square of 15 are not whole numbers. How? A calculator can approximate the value of root square of 15 at 3.879, 29833 and so on. Without a calculator, you can use square roots of a perfect squares to help estimate. Estimate means what before root square of 15 and what after root square of 15. If you think with me, you'll find out that what was 15, root square of 15, you'll find only 9. But what after that, you will find only what? You will find only 16. Why? Because we will find out that the ratio which always close the root square, it will be my closest answer. That's why whenever we think about that things, we'll see exactly how can we do that. Problem solving application, which we have it as part of here art projects, shown that we'll need to make a square covered in glitter. You know the glitter which used in the art room. Here tube of a glitter covers 13 square inches. We have 13 square inches. She needs to decorate it, to cover it with the glitter one, which is bright and the bright color flourishing. So 13 square inches. What is the greatest side length the square can have? So the answer will be the side length of the square, which is equal 13 square inches. That's why we'll find out that the value for us will be here. The side length of the square is root square of 13, because root square of 13 multiplied by root square of 13 equals 13. But 13 itself is not a perfect square. Why? Because it's not a whole number. Estimate the square root of 13 to the nearest 10th. What does it mean here to the nearest 10th? Because 13 is between the root squares from 0 up to 16 on the number line. You will find out that the root square is between, as I explained to you the last previous the last slide, is between root square of 9 and root square of 16. طب what is the root square of 9? Equal 3, right? And what is the root square of 16? Equal 4. So in fact 4 is between 3 and 4. Is between what? 3 and 4. So in the number lines here we can say that 13 is closer to 16 more than 9. That's why the answer here says that the root square of 13 is closer to 4 than 3. And that's exactly what we have here in this example. This example, it really make you more rich in the information and to find out the solution faster, better than your original presentation, which you have it. I would like to use it, but this is an additional resources for you to make sure that the same concept is the same whenever you understood that concept, so you can apply it everywhere. So guess about 3.6. 3.6 power 2 or square equal 12.96. It is also the same. Root square is greater than 3.6. Let's try which one closer to 3.6 to my solution or 3.7 to my solution. So root square of 13 is greater than 3.6 because I tried 3.6 power 2 equal this value. Type 3.7 power 2 equal to that value. Which one closer to the answers which I have it here in the number line? You will find out that 3.6 for 13 root square 13 and 3.7 for 16. Which one closer? We'll find out that 13 is closer to the first value. 13 is closer to 12.96. That's why the answers will be approximately or almost 3.6, not 3.7. Why? Because 13 root square of 13 equal exactly or closer to 3.6 power 2. That's why whenever we look at the example, it will facilitate many things to understand. A square with a side length of 3.6 inches would have an area of 12.96, which almost equal 13 if you round it square inches, because 12.96 is close to 13. Why? 3.6 inches is a reasonable state, right? For the estimation, I'm sorry. So from that one, we can say that what if Nancy decides to buy more wildflower seeds and now has enough to cover 38 feet square? What is the side length of a square garden with an area of 38 square foot? Use a guess and check methods to estimate root square of 38. Again, root square of 38 could be what? Could be here 6.1 or less than 6.2. Could be greater than or less than. So guess about that one. 6.1 power 2, it's equal 37.21. While the other one, 6.2, equal power 2, of course, equal 38.44 too high. So which one is closer? I think that 6.2 is more reasonable. Why? Because 6.2 is closer to the answer. Why? Because 38, it is the final answer. And this one, if it's rounded, it will be 37. This one, if it's round, it will be 38. So the closest answers for our problem, it would be what? It would be 6.2. 6.2 is closer or much closer to our answer to be reasonable one. So now here we have already the answer and we have the reason. All numbers that can be represented on a number line are called real numbers. What are the real numbers? Real numbers could be rational and could be irrational numbers. Why? Because we can classify them according to their characteristics, their features. Find out that rational numbers, it could be number one, rational numbers which has integers like -3, -2, -1, and it's reflected, its opposite parts like 1, 2, 3, 4, and so on. Whole numbers like 0, 1, 2, 3, 4, including 0. Natural numbers 1, 2, 3, 4 without the 0. So in this case, the rational numbers could be number one, integers like -1, -2, -3, and 0, and 1, 2, 3, 4, and so on. Now what about the whole numbers? 0, 1, 2, 3, 4, 5, 6, all the positive ones, including 0. What about the natural numbers? all those numbers without the zero, 1, 2, 3, 4, and so on. What about the irrational numbers? Irrational numbers could be decimal, or could be the none, exactly the same number, which we can have it as a whole number, like root square of 17. 17, it should be at least here like divisible by some numbers to give us, for example, like 4, root square of 4, root square of 9, root square of 121, root square of 144, root square of 36, root square of 81. We can divide it by itself or multiply by itself, but here it's completely different. Like pi, 22 over 7 or 3.14. Any decimal numbers. Anyway, we will have the definition of everyone. Natural numbers, they are the counting numbers 1, 2, 3 without zero. Whole numbers are the natural numbers and the 0, 0, 1, 2, 3, and so on. Integers are whole numbers and their opposites, negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on. Rational numbers can be expressed in the form of A and B, while the irrational numbers cannot be represented or expressed in the form of A over B. But if the rational number says that the relationship which expressed or can be expressed in the form of AB, just make that in your mind that the B never equals 0. Not equal 0, as we said it as a condition here. So the next one for us here, saying that what are the terminating decimals? Terminating decimal are reasonable numbers in decimal form that have a finite number of digits, like 1.5, 2.75, and 4.0, and so on. While repeating decimals are reasonable numbers in decimal form that have a block of one or more digits that repeat continuously. Remember, whenever we divided 2 over 5 or 5 over 6, we do have repeated 3, we do have repeated 6. That's why we wrote 3 dash and 6 dash and so on. Irrational numbers cannot be expressed in the form of AB. They include square roots of whole numbers that are not perfect squares, and non-terminating decimal that do not repeat. It's exactly like the square root of 2, square root of 11, and the pi. So also, we will have some examples here, classifying real numbers. Write all classification that apply to each real numbers here. Negative 32. Negative 32, every number divisible by 1. So negative 32 equal negative 32 divided by 1. Even if it was like a fraction, so it will be negative 32.0. But in this case, we cannot consider it as non-rational numbers. It's exactly like rational numbers, integers, or terminating decimals. While the second one, 5, also the same here. 5 can be written as fraction and decimals, 5 over 1 or 5.0. So it's rational numbers, integer, whole number, and natural number, and terminating decimals. We can figure it and we can shaping it. So 7 and 4 over 9. Think about it. 4 over 9 divided, right? Division and divisible by 9. So 4 over 9 equals 0.44444 infinity 4. That's why we'll say the results equal 7.4 dash. That's why it's not terminating, but it's rational number and repeating decimals. Why? Because we do have here repeating decimals. Also, negative 12. Negative 12 divided by 1 or negative 12.0, it means rational numbers and terminating decimals. What about the root square of 10 equal 3.162? It means decimal. It means here it's a decimal one. But the digits continue with no pattern to do that number. That's why it's irrational numbers. Now, come again to the other one. Find its square roots. Root square of that one, which we can consider that one to be as our rational number. Look at it and try to find out how can we find out that things as a lesson quiz. I will give you just to think about it. Root square of 144. Did you think about 12? Yes, 12 power 2. So we can say 12 power 2. 12 times 12 equal 144. What about the second one? Negative root square of 64. Negative 8. Why? Because 8 times 8 equals 64. And the negative multiplied by the radical symbol. Number 3. Root square of 9, 49. 9 could be 3 power 2. 49 could be 7 power 2. So 3 over 7. But also 4. Number 4 here. Negative root square of 1 over 4. The 1 could be 1 power 2. The 4 could be 2 power 2. So it's equal negative 1 over 2. Negative half. So the area of a square piece of cloth is 68 inches per 2. How long is each side of the piece of cloth? Round your answer to the nearest tenth of an inch. In this case, think about it. Why? Because the 68 inches, if we look at it, it will be what? How can we calculate it? The area of square piece of cloth of 68. It's close to the what? 68, close to 64, right? Close to 64. It means 8. It's much closer to these results. 8, it's much closer to this result. So it could be 8.2. If we consider that, which one close? 8 only or 8.2? So if you consider that one, we can say that 8.2, we can say 8.2 times 8.2 equal 67.24, right? 67.24. And we do have here 68, right? Right? 68 inches. Right, 68. Right. While the other one, which we can say that 8.3, let's see 8.3. 8.3 times 8.3 equal 68.89. It means that approximately or rounded to be 68.89. It means 69. But here, in fact, for us, it will be 68. So the proper answer for us, it will be 8.2 exactly inches. Okay, so just to try it, and you will find out that the answer close to that one. That's why we need to understand how can we find out the closest answer to be reasonable to do that. Okay, the area of square piece of cloth is 68 inches. And in that case, we need to round the answer to the nearest tenth. So after that, write all classifications that apply to each real number. Number 1 could be rational, could be integer, could be whole number, could be natural number, could be terminating decimal. Number 1, rational. Yes, it's rational 1 because there's a whole number. Integer, yes. The third one, whole number, yes. Natural number, 1, yes. Terminating decimal, we can say 1 over 1, right or not? So 1 over 1, we can say that it will be the same, 1, okay? So by this way, we can say and we can understand this is the decimal, the terminating decimals, right? Also for the other one, which we can have it done before, if you remember, do you remember that whenever we have that before as a terminating one or as a rational one? I'm trying at least to think with you. 1 divided by 1 equal 1.01. I'm sorry, 1.0 equal 1.0, because I know that this is the hardest point for you. That's why I need everyone to understand how can we find out the terminating decimals. So again, the first one could be rational number, could be integer, could be whole number, could be natural number, could be terminating decimal, as we have it here. But what about the second one? Negative 3.89 repeated. Of course, the repeating one is a 9. So it could be what? It could be rational. Yes. It could be repeating decimals. That's it. But never being a whole number, never be integer, never being natural number. That's why we can say rational, right? Rational one, and we can say what? Repeating decimal. But what about the root square of 500? It's only rational. It's only rational. We cannot say that they are whole number. We cannot say integer. We cannot say natural number. We cannot even say terminating decimal. Of course, I have already tried my best to everyone, and I want everyone to understand that we have here to help you. We have the chance to simplify the information for you. I'm sorry if I found out some points for you and they need to be more clarified or more explained. But if you have any question, don't hesitate to call me or email me or text me or whatever. Just you can wait for me in the class, and you will find out my door open all the time. And you know, we are sitting together. We have the same family, and I hope to see you exactly at the science subject with you, inshallah. From this Tuesday, whenever we come back to school, Monday or Tuesday, we are going to set our scheduler for formative and summative test for the chapter 9. And don't worry about the final test, inshallah. We are going to do our best to make it simpler and to make it really summatives for all the year, because we need to prove to everyone that you are very good students, and for me at least the best. And inshallah, I'm going to see all of you in the future, something valuable and great personalities, and I hope the best for everyone. Enjoy your time. Have a nice end of that day, and tomorrow inshallah we're going to meet together during our class. Don't forget to download the Socrative software, and don't forget to make your accounts, and just copy and paste that code which I'm going to deliver to you in the early morning, exactly in our timetable, in our scheduler. We have the first 2 periods of science will be together during the class of science, and then after that during the math classes in the same time. The people who they will be available and exist in my class, I mean in my room in the Socrative, and listening to my explanation through this presentation, I hope that to have and deserve their bonus whenever they have it. And you know, the good students for me, always the top students, always the students who deserve the help and the hint and the bonus, while the others, God help them. I hope that everyone to find out the best for himself and the best for his parents. I want your parents to be satisfied and happy for your results. Thank you very much, and have a nice night.